So in the last video, we did complex plane, how to represent a complex number on complex plane. Now we will do how to add two complex numbers. So let's say that we have a complex number z. As you can see on this graph, two complex numbers have already been plotted. So first one is z, which looks like 3 minus 8i, and the second one is w, which is, yes, you can pause the video and tell. So it is 6 plus 2i. Okay, and we have to add these two. Now, if you remember in Algebra 2, we did how to add two complex numbers. So first, let's quickly revise how we used to add two complex numbers. It was very simple. We just used to add the real parts together and the imaginary parts together. So if you were to add these two, so you're going to get z plus w is equal to, you add 3 and 6, the real parts together, so you get 9, and you add the imaginary parts together. So negative 8 plus 2, that's negative 6i. Yeah, so this would be the value of z plus w. But now, if you're not allowed to do it arithmetically and you only have to do it graphically, so how do we do that? So there is something called parallelogram rule of addition. Okay, we will also do it in when we'll do vectors, but we can use it in the case of complex numbers as well. So let me just write it here. Okay, parallelogram. I hope you guys can recall what is a parallelogram. If not, you can pause the video and just rewind your memory. Okay, so parallelogram rule for addition. And I'm a very structured person. I just need to draw a line below every heading. Okay, so what is this parallelogram rule for addition? Now, let's say I'll just first use an example, then we'll go back to this problem. Okay, let's say you have a complex number u and you have another complex number v. Okay, and you want to add them. So what we'll do is first we will plot both of these complex numbers on the complex plane. Okay. So for example, here you have w and here there is z. Okay. So what we will do is we will connect the segments. Okay. So let me just write this. The segments connecting the complex numbers u and v to the origin are sides of a parallelogram. Sides of a parallelogram. Oh my God, this is such a long word. Don't worry, I'm going to explain everything. Parallelogram with vertices 0, comma u, comma v, and u plus v. Now, what does this statement mean? So this is the statement of parallelogram rule for addition. We'll understand what does this mean. See, if you have recalled by now, a parallelogram is a four-sided figure, right? which has two pairs of parallel lines, right? So let me just draw it. I'll try my best to draw a parallelogram. Right, so this is how a parallelogram looks like. Okay, so this says that this parallelogram rule says that the segments connecting the complex numbers u and v to the origin. Now, let's say that this point is your origin, right? On the complex plane, this is your origin, and this is the complex number u. This is the complex number v. Okay. Now, this segment, this is one segment which is connecting u with the origin, and this is another segment which is connecting v with the origin. Okay. So these two segments, right? This segment and this segment. These two segments are sides of a parallelogram with vertices 0, u, v, and u plus v. See, one vertex is 0, right? One vertex is 0. A parallelogram has 4 vertices, right? So you have 1, 2, 3, 4 vertices. So one vertex will be always the origin. Another second vertex will be your u, which is the first complex number. Third vertex is v, which is your second complex number which you're adding. And fourth vertex is your u plus v. Okay, and this is what you actually wanted to find out. And if you notice carefully, this is nothing but the diagonal of this parallelogram, right? So this parallelogram, another statement for this parallelogram rule is that if you have a parallelogram with vertices origin, u and v, then the diagonal of this parallelogram starting from origin will give you the coordinates for u plus v. Now let's come back to our question. It will make things much clearer for you. So what I'm going to do now is I'm going to see, I have two complex numbers, w and z, right? And I want to find out what will be w plus z. So what I'll first do is I will connect these two complex numbers with the origin. Okay. This is the origin. I'm going to connect it. Let me take a darker color. Let's take blue. So connect w with origin. Oops. And connect z with the origin. Now you have to complete this parallelogram. Okay. You have got two segments, right? This is the first segment and this is the second segment. Now you have to complete the parallelogram. So how can you do that? Da, da, da. Yeah, this looks like a line parallel to this line and connected from here as well. So now we have completed the parallelogram. And so this is your first vertex, your second vertex, your third vertex, and this is the fourth vertex. And this is nothing but z plus w. So what are the coordinates of this point? Is it this? Let's see. Yeah, this point is 9 and this point is -6. Okay, so this is what 9, -6. So your z plus w is 9 minus 6i. And we also did it mathematically, right? We did it algebraically and we got 9 minus 6i.